Hi guys, so in this part 2, let's see how to find out error and how to give correction to the error, right? So once again, let's recall about Vernier calipers, very simple quick review, right? Here, if you observe carefully, this is main scale, right? On main scale, it will be like a normal centimeter scale only, and it is Vernier scale. Whenever you place the object between jaws of Vernier scale, then this Vernier scale will move freely on the main scale, right? If you observe these readings, if you zoom this, then it appears like this, right? So if you observe this reading, whenever there is no object between the jaws of Vernier scale, then the zero of main scale should be coincide properly with the zero of the Vernier scale. Then the Vernier caliper said to be have no zero error, I mean it has zero error. Okay na? So zero error in the sense exactly zero is coinciding with zero of the Vernier scale right now. So now here, just let's again once like once review small things which we have discussed in the last class. If you observe carefully, here there are 10 divisions. 1 centimeter is divided into 10 divisions, right? 1 centimeter is equals to nothing but 10 divisions. Now from this, why I can tell that 1 by 10 centimeters is equals to 1 division. We have taken this 10 this side. Then what happens? From this, 1 division is equals to 0.1 centimeter. So what is this 1 division? This is nothing but this gap, right? This gap is 0.1 centimeter. So now here, uh, I mean I can tell that one division on main scale is 0.1 centimeter. Coming to the Vernier scale, if you observe Vernier scale, there are 10 divisions: 1 2 3 4 5 6 7 8 9 10, right? So 10 divisions are there on main scale, I sorry, on Vernier scale. So these 10 divisions are coinciding with the 9 divisions of main scale. 1 2 3 4 5 6 7 8 9, right? So means what I can tell now from this, 9 divisions of main scale is equals to 10 divisions of Vernier scale. 10 divisions of Vernier scale. So now what we can do here, let us find out one division. If you take this and 10 this side, 10. And one more thing is here, you must remember that one division on main scale is 0.1 centimeter na. Then how many divisions are there on the main scale? 9 divisions. So I can tell that 9 into 0.1 centimeter, that is equals to 10 divisions on Vernier scale. So now here if you observe, 9 into 0.1, 0.9 centimeter, that is equals to 10 divisions on Vernier scale. Okay na? So from this, if you send this 10 this side, then what happens? 0.9 by 10 centimeter is equals to 1 division on Vernier scale. So from this calculation, what we can tell is 1 division on Vernier scale, 1 division on Vernier scale is equals to nothing but 0.09 centimeter. Okay na? So now here, if you observe carefully, what is the gap between this first one and this one? If you observe carefully, if you want this small gap, that is called nothing but least count. Least count is nothing but one main scale division minus one Vernier scale division. Then you will get this small gap. Okay na? This small gap between these two layers, right? So now least count is nothing but one main scale division. What is the one main scale division? 0.1 centimeter, right? Minus, and one Vernier scale division. What is one Vernier scale division? 0.09 centimeter. Now if you do this, you will get 0.01 centimeter, right? This is the least count of Vernier scale, right? So now here, whenever the Vernier scale moves forward, whenever you keeping the object, then what happens? The Vernier scale moves forward. In that condition, if the first digit of Vernier scale coinciding with the first one of this, then the Vernier scale has moved forward for 0.1 centimeter, right? Then I can tell that the length of the object is 0.1 centimeter. For example, if you observe one more case here, if you observe one more case, this is 0.1, this is also 0.1. What is total length? It is 0.2 centimeter, right? And next, this is 0.09, and total is 0.9 plus 0. I mean 0.09 plus 0. Now here the total distance is, I can tell that 0.18 centimeter. Clear? Now while the Vernier scale moving forward, if second line, if this line of main scale is coinciding with the second line of Vernier scale, that means the Vernier scale has moved forward for, so you do subtraction, it will be like 0.02 centimeter. That means if you observe carefully the gap, if you observe carefully, let me take here, right? The gap between these two lines is 0.02 centimeter, and the gap between these two lines is 0.01 centimeter. Now it mean like likewise the gap between these two is nothing but, you can tell easy, 0.03 centimeter, right? Now can you guess the gap between these two? It is like 0.04 centimeter. Now the gap between these two is, it is like 0.05 centimeter. Now this gap is nothing but 0.06, 0.07, 0.08, and this gap between, this gap is 0.09, and 10th one is coincide. Clear now? So this is how Vernier calipers works, right? If the first one is coincided with the first thing, then how much distance the Vernier calipers has moved? It is distance like 0.01 centimeter, right? Hope you understand. So this is how we measure by using the Vernier calipers. And if you observe, if you observe, whenever you have observed Vernier calipers, if zero of main scale is coinciding with zero of Vernier scale, then the Vernier scale said to be have zero error, right now. So there is no positive error, there is no negative error, exactly it has zero error, right now. So next, let's go to the next slide. uh, there are two types of errors. One is positive error, another one is negative error, right? What is error? The uncertainty in the measuring is called error, right? So here if you observe carefully, uh, in this condition and this conditions, what happened? uh, the zero of Vernier scale is forward to the zero of main scale, right? So that means it is nothing but negative error, it is nothing but a negative error, right? So now the zero of Vernier scale is coinciding with zero of main, not coinciding, forward to the zero of main scale. So we can tell that it is nothing but a negative error. So for this, if you observe carefully, uh, if you want to measure in such case negative error, so error is equals to main scale reading plus least count into coinciding division. Okay, now remember this, just normal formula. Here, since it is negative error, you observe carefully which line is coinciding properly. So I can tell this line. See, if you observe this line, what is this line? This one. Okay, na? 5, 6, seventh one. The seventh one is coinciding very well. So now main scale reading is 0 plus least count is 0.01 into, and here the seventh one is coinciding na. So for negative error you must calculate from this side, 1 2 3, right? Or else you can do one thing, whatever the coinciding point, 10 minus coinciding point, do this to calculate the negative error. Okay na? Right? So now what happens here? 0.01 into 3, so 0.03 centimeter. This is the negative error, this is the negative error for this diagram. And if you want correction, the correction for this, adding, since it is negative error, whatever the value you get after measuring, For that you have to add this value 0.03 for the reading which you get. Okay, na? So this is about the negative error. Whereas coming to positive error, positive error in the sense nothing but the zero of vernier scale backward, I mean next to the zero of main scale. Okay, na? Right? So here if you observe, let us take for this also, for reading this same formula again, main scale reading plus least count into coinciding division, that is equals to, here when there is no object between the jaws of vernier scale, this kind of arrangement you have seen, which is called positive error, right? So now here, this which one is coinciding well? 5, 6. The sixth one is coinciding well, right? So main scale reading is 0 plus and least count is 0.01 into what is coinciding division. Sixth one is coinciding. Here no need to take 10 minus. Okay. Here we have taken 10 minus 7 because we are measuring negative error. Okay. It is advanced. It is a backward right now. So that's why we did not take here. If you are, if the seventh one is coinciding, then you consider it as a 3. Leave the first one and you can measure, right? Now here what happens, the error is 0 plus 0.06, that is equals to 0.06 centimeter is the positive error of the vernier calipers. Right now, now let's go to the next slide. I hope it is very clear. Coming to the next one, yeah, here also same thing. See, this is nothing but a vernier calipers. This is a main vernier scale and it is main scale. So now first of all you should find out the least count. Or of course by seeing this here you can tell that here it is 10 nana, not 5, right? So now if you observe carefully, the zero of vernier scale is advanced to the zero of main scale. So I can tell it is a negative error. Okay, na? Left side of the main scale it is there, right? So it is negative error. The error is, sorry, the error is negative, right? And now what is the reading of it? When your main scale reading plus least count into coinciding division, right? So 0 plus least count is 0.01 into, coming to coinciding division, I told you already for negative error you have to take 10 minus, which point is coinciding well? Yeah, exactly fourth. See, if you see this fourth point, the fourth lines are coinciding well. Okay, na? The fourth lines are coinciding well. Okay, na? The fourth one is coinciding well. So that what you can do, you can write 10 minus 4. Then that is equals to nothing but 0.01 into 6. Then you are getting 0.06 centimeter. This is the error of this diagram. Hope it is very clear, right? Let's have one more example. Let's have one more. Yeah. So here, positive zero error, right? Positive zero, and the zero of vernier scale is uh, backward to the zero, mean right side of the main scale zero. This is nothing but positive zero error. Coming to here, main scale pause for positive, same formula. Main scale reading plus least count into coinciding division, right? So now what is main scale reading? It is like 0 plus what is least count, 0.01 into which, yeah, exactly the fifth one is coinciding well, right? You take it as a 5. Now what happens, 0.05 centimeter is the error, right? This is about positive error. And next let us see one more example we have. So here they gave two readings, okay na? And let us consider there is no error, okay na? Zero error, no positive error, no negative error, right? Now let's measure measurement of this object. What is this? They kept an object between the jaws of the vernier scale, then these are the readings they are showing. Now here the first one, C1, the reading of C1 is equals to nothing but main scale reading plus least count into coinciding division, right now. What is main scale reading? This is 2, 2.5, 2.6, 2.7, 2.8, 2.9. So we can take 2.8. We cannot take 2.9. 2.8 plus 0.01 into which one is coinciding well? The sixth one is coinciding well. If you observe, right? The sixth one is coinciding well. Then all the sixth one is exactly coinciding. So you take 6. Then what happens? 2.8 plus 0.06. I can write 2.86 centimeter. This is the least count of sorry, this is the reading of the first one. For example, imagine there is error in this reading. This Vernier calipers. For example, if the error is 0.02 centimeter. If the error is negative error, then you add this. Then what will be the reading? Will be 2.88 centimeter. Here, 2.86 is called observed reading, and this is called real reading. Okay, na? And next, for example, if you have positive error, then what is the reading? 2.84 centimeter. This is the reading, true reading. And it is observed one, right now. Next comment, let us see the second one. This is also the same diagram they have kept two times. Yeah, hope you understand very well about vernier calipers. If you have any doubts, and you can please comment below. I'll approach it. Right. Thank you.